or good afternoon. This is your lesson on 6.5, and in 6.5 we're basically going to go backwards with 6.4, where we're going to figure out whether or not we're looking at a rectangle or a rhombus, or the combination of the two, a square, which of course means we need to know our properties from 6.4 because we're just going in reverse. All right, homework this evening is going to be 6.5 Math Excel. It's only 14 questions, and it will not take long, I promise you that. Please note we're not doing any more quizzes, but we're going to do a test, and it's going to be a 2-day test. We're going to do a group test on the 5th and an individual portion test on the 6th. And we're at the end of this lesson, we're going to do a 6-5 check for understanding. Let's get going. Here's your first theorem of the day. If I have been given a parallelogram, and in this parallelogram I have diagonals, so I have diagonal AC, and I have diagonal BD right here. If they are perpendicular, then I know I have a rhombus, which of course means by definition that all four sides are congruent. I'm not going to formally prove this to you, but I'm just going to start to think about why this is true. If we think back to one of our properties of parallelograms, we know that opposite sides are congruent. So we would know that AD is congruent to BC and AB is congruent to DC. We ultimately need to show the fact that AD is congruent to AB. Well, we could do that by proving that these two triangles are in here. So if I call this middle point here E, AEB is congruent to AED, okay? So we could use the fact that they both share this side right here. They both have a right angle, but then of course we're going to need to have one more property, okay? And so the other property that we're going to need to have is the fact that BE is the same length as DE, because one of the other properties of parallelograms is the fact that diagonals bisect each other. So voila, you'd have side angle side, which of course means we could use CP CTC to show that AB is congruent to AD, which then of course, because all opposite sides are congruent, AD is congruent to BC, which is congruent to AB, and so forth and so on. Let's get into your other properties, aka the converses of the last lesson. If you have a parallelogram and you have opposite angles that got bisected, so angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, then you may conclude that you have a rhombus, which of course means all four sides are congruent, okay? But the other topic we learned about before Thanksgiving break was rectangles. So here's your theorem about rectangles. If you have a parallelogram and you have congruent diagonals, so AC is congruent to BD, then I may conclude that I have a rectangle. Now please recall that some of the properties of rhombuses and rectangles carry over onto squares. And in order to have a square, you would need to have a combination of theorem 617 with 618, or theorem 618 with a combination of theorem 616. All right, let's get into our first example problem. We're trying to conclude whether or not the shape that we're looking at, which is a parallelogram, is a rhombus, a rectangle, or a square. Always be as specific as you can possibly be. So looking at this parallelogram, I noticed that this diagonal came along and it bisected two pairs of opposite angles. So therefore, I may conclude that I have a rhombus, okay? Just by giving this information, I know I have a rhombus. Here's my next example. I have been given a parallelogram. Let's make some observations. The first observation that I can make is the fact that the diagonals are perpendicular to one another. Because the diagonals are perpendicular to one another, I know I have a rhombus. But the other piece that I can see is true is that all these little tiny diagonals got bisected, which again is a property of a parallelogram, but because they all have a single dash, that tells me that the entire diagonal is congruent to the entire diagonal, and therefore it is a rectangle. So if I have properties of both a rectangle and a rhombus, I can conclude that I have a square. Here's your got it question. You have two of them. A parallelogram has angle measures of 20, 160, 20, and 160. Can you conclude that it's a rhombus, a rectangle, or a square? Explain. Question B. Suppose the diagonals of a quadrilateral bisect each other. Can you conclude that it is a rhombus, a rectangle, or a square? Explain. Let's check your answers. In question A, because you don't have information about whether or not the angles are right angles, you cannot say that it is a square or a rectangle. However, you could say potentially, notice I said might, it might be a rhombus. Notice I can't for sure say it's a rhombus because I don't know if the four pairs of opposites or the four opposite sides are all congruent. And in question B, it says we cannot conclude because the fact that the diagonals bisect each other is true for all parallelograms. Let's get into the next question. For what value of x is ABCD a rhombus? Well, if we think back to Theorem 617, which of course I don't really ever call it Theorem 617, in order to be a rhombus, my opposite angles needed to get bisected. So 1 and 2 would have to be congruent. So I must use this idea in this problem. Angle ABD needs to be congruent to angle CBD. And if they're congruent, I need their measurements to be equal to one another. So I'm going to set their expressions equal to one another. So 6x minus 2 equals 4x plus 8. We then need to solve for x, so I'm going to subtract the 4x, I'm going to add the 2. And that gets me 2x equals 10. And then divide by 2, that gets me an x value of 5. So long as x is 5, these angles are congruent, and then I have a rhombus on my hand. All right, your turn. For what value of y will this parallelogram be a rectangle? So what property do you want to be true in order for us to guarantee that what we're looking at is a rectangle? Let's check your answer. Did you get an answer of y equals 4? If you did, you're on a great track for this section. All right, let's do the final example problem. Builders use properties of diagonals to square up rectangular shapes like building frames and playing field boundaries. Suppose you're on a volunteer building team at the right. You are helping to lay out a rectangular patio for a youth center. How can you use properties of diagonals to locate the four corners? Well, in order to have a rectangle, we need to have properties of rectangles. So the first thing I'd like to make sure that happens is that I'm going to have diagonals that bisect each other, as well as if the diagonals are going to be congruent. So long as these two facts are true, then I've guaranteed that I'm looking at specifically a rectangle. So the first thing that my team and I need to do is make sure we have ropes. And the ropes need to be the same length. So long as they're the same length, then they have created congruent diagonals. Then my team and I need to find the midpoints of these ropes. When I find the midpoints, I'm going to make sure that they connect to one another. And then we're going to pull our ropes such that we have guaranteed that they have bisected each other. Ta-da! My team and I have created a rectangle. We definitely do this in the real world. Your turn. How could your team make this a square play area? What's one more property that you need to have happen? Let's check your answer. We need to make the diagonals perpendicular. So your team needs to make sure that when you pull your rope, you create right angles at the midpoint. Congratulations, you've just learned section 6.5. We only have 2 more lessons left to learn for this chapter. Please log on to Schoology at this time and complete the 6.5 check for understanding. You may use your notes as you are currently learning the lesson today. Have a great day.